Okay, let's dive right into this. Welcome to this explainer. Now, today we're doing something a little bit different and frankly, absolutely game-changing. We are taking the psychologist approach to your math exams. That's right. We are getting directly inside the examiner's head to know exactly what they're really asking you. Look, whether you're taking 0606 Additional Mathematics or 0580, 4024, 4037, or even 4040, you already know these are demanding syllabuses. But there's this one specific area that consistently trips up even the sharpest candidates, using the maximum or minimum value of a function f of x to sketch a graph or to determine the range for a highly specific domain. Picture a typical past paper question. On one side, you got a student, let's call him Alex. Alex overloads his answer with raw mathematical facts, writing down every formula he knows but with zero actual analysis. On the other side, you've got Sam. Sam rushes, completely misses the specific command word requirements, and calculates things the question didn't even ask for. They both end up with a page full of red pen marks. Today, we're going to decode the examiner's playbook so you don't end up like Alex or Sam, and instead secure those top-tier marks. I want you to really look at this benchmark. This is pulled straight from the syllabus. Examiners are explicitly looking for a connected, conceptual understanding transferable to unfamiliar contexts. So what does that actually mean for us? It means they absolutely do not want superficial memorization. If you just memorize the rigid steps to complete the square or find a derivative without understanding the why behind it, you're going to hit a brick wall the moment a question looks even slightly different. The examiners are hunting for deep, logical reasoning. They want to see that you get the underlying mathematical story the function is telling. If they throw a curveball at you in the exam, and trust me, they will, your foundational understanding needs to be strong enough to adapt on the fly. Which brings us to the core challenge, really. Why on earth do students find evaluating mathematical evidence and drawing conclusions so incredibly difficult? Think back to our typical students, Alex and Sam. When it comes to finding the max or min value to sketch graphs, it is almost universally misunderstood. You see, Alex treats calculating that turning point as the final destination. Boom, derivative equals 0, find x, done. But in reality, that calculation is just the raw evidence. The real test, the part where the examiner actually awards the biggest marks, is how you evaluate that evidence. Does that specific minimum point actually fall inside the restricted domain they gave you? What does it mean for the absolute highest and lowest y values? That jump from raw calculation to critical evaluation is where the battle is won or lost. To help you completely master this, we're going to follow a 4-part roadmap today. 1. Core principles. 2. The procedural framework. 3. Critical analysis. And 4. Top examiner warnings. Let's kick things off with Section 1, Core Principles. It's all about thinking like the examiner. Okay, so the assessment objectives target 3 distinct cognitive steps, building from the ground up. It's not enough to just know a formula. Knowledge is knowing that the first derivative equals 0 at a stationary point. Application is actually finding that point for a complex function without messing up your algebra. But analysis, that is the highest domain. That's evaluating whether that specific minimum point dictates the overall range. This is where top students use the Peel framework. Point, evidence, explanation, link. You make your point about the max value, show your evidence through calculus, give an explanation of why it's a maximum using the second derivative, and link it back to the specific domain in the question. And hey, before we continue, subscribe to our YouTube channel Ace the Exams at aceexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You need to prove mastery across all these domains to unlock the top tier of grades. Moving right along to Section 2, the procedural framework. We like to call this the method mark strategy. Listen, you must walk through this strict, 5-part standardized sequence. This is your mathematics success blueprint. This is how you turn Alex and Sam's red cross marks into green check marks. Step 1, identify key elements. What is the exact function and domain? Step 2, apply relevant principles. Are we using differentiation here or completing the square? Step 3, execute the analysis. Find the coordinates of your max or min values and do it with crystal clear working out. Step 4, verify your results. Use the second derivative test. Check the boundary values. And Step 5, present the format. Draw the sketch properly or write the range with the correct inequality signs. If you stick to this blueprint, step by step, you are literally guaranteeing yourself maximum method marks. Now, within that execution phase we just talked about, your data interpretation skills are absolutely critical. You might be sitting there thinking, texts and tables in an algebra exam? Yes, absolutely. You have to extract the exact parameters from the text of the question itself. Remember our friend Sam who rushes?
Sam loses marks here by failing to interpret the relationship between the turning point and the domain boundaries. Let's say your minimum falls at x equals 3, but the text strictly limits the domain to x between 4 and 10. Guess what? That minimum you just spent 3 minutes calculating is completely irrelevant to your range. Drawing evidence-based conclusions means using the specific data you extracted to build a bulletproof final answer.
And we really cannot talk about method without hammering home presentation conventions. Deconstructing the question requires adhering to these strict rules. When you are asked to sketch your graph of y equals f of x, clear annotation is non-negotiable, guys. Label your axes. Label the coordinates of the maximum or minimum point. Clearly mark where it crosses the y-intercept. Use correct terminology. Formatting isn't just about making your paper look pretty for the examiner to give them an easy time grading. It is the literal language of mathematics. Presenting it correctly is how you prove that conceptual understanding we've been talking about.
Let's transition into Section 3, Evaluation and Critical Analysis. This is all about elevating your grade from average to outstanding. Notice the massive contrast in how top students operate compared to the rest. Average students just calculate blindly, but top-scoring candidates, they actively question assumptions. They justify their decisions with hard evidence. If you find a stationary point, don't just blindly assume it's the absolute maximum for the whole graph. Evaluate its quality. What are the limitations? Check those endpoints of the given domain. Often, the value of the function at the boundary is actually higher than the local maximum you just calculated. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump into a quick interactive workshop. Challenge 1, data scan. Imagine a complex data table on screen right now. You've got 60 seconds on the clock. Your job is to extract the core trend. Is the function increasing or decreasing as it approaches the boundary? Top students spot that trend instantly. This perfectly builds into how you compare data points. In the context of max/min values, this means evaluating the effect of your different critical points. You calculate the y value at the turning point, right? And you calculate the y values at the ends of your domain. Now compare them. Identify the similarities and differences to support your final conclusions. Let's do Challenge 2, find the flaw. Imagine a paragraph that says, the turning point is at y equals 5, so the range is y is less than 5. Spot the flaw? The student didn't check the domain boundaries. That's where you lose marks. Which brings us to Challenge 3, speed writing. You got 30 seconds to write a perfect Peel paragraph. Point, the max value is 10. Evidence, derived from completing the square. Explanation, the coefficient of x squared is negative. Link, therefore for all real values of x, the range is f of x is less than or equal to 10. That comparative structured analysis is what clinches the absolute highest marks. All right, moving to our final critical section, Section 4, Top Examiner Warnings. These are the exact pitfalls you need to avoid. Examiner warning number 1, students simply forget to include the proper format. Honestly, you would be absolutely amazed at how many candidates do the incredibly complex calculus or advanced algebra perfectly. They find the correct maximum value, and then they just stop. They fail to actually sketch the graph the question asked for, or they find the correct boundary values, but fail to write the final answer using the correct mathematical notation for range, like y is greater than or equal to. They do 90% of the hard work and literally throw away the easy presentation marks at the finish line. Do not let this be you. The second major pitfall we see over and over is pacing. Remember Sam? Sam's biggest enemy is the clock. Students are rushing, racing against the time limit, and because of that panic, they fail to double-check their presentation and format. They sketch a beautiful curve but forget to label the coordinates of the turning point they just spent 5 minutes finding, or they draw the curve extending way past the restricted domain given in the text. Rushing causes you to skip that vital verification step from our blueprint. Always take a breath, pause, and check your work against the specific constraints of the question. The third massive warning is providing generic answers. Cambridge examiners consistently note in their reports that students provide responses that are not specific to the actual context given in the question. Think about it. If the question gives you a real-world model, let's say it's an equation modeling the height of a projectile over time, your range must make logical sense in that physical context. Time can't be negative, right? Or if the domain is strictly defined for x greater than 0, your graph sketch must not extend into the negative x-axis. Your final answer must be flawlessly tailored to the specific scenario the examiner has set up. And this brings us to a massive, high-impact alert directly from the principal examiner reports.
candidates consistently confuse key terminology. It's a tragedy. They mix up domain, which are your input x values, with range, which are your output y values. They confuse a local maximum with an absolute maximum across a whole restricted domain. When you are writing out your reasoning, make sure your terminology is razor sharp. Knowing the difference between these terms and deploying them correctly in your explanation is the ultimate signal to the examiner that you have that connected, conceptual understanding we talked about at the very beginning of this explainer.
So, there we have it. We've totally decoded the examiner's playbook. Before you take another exam, remember the final system. 3 rules guaranteed top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, the time management matrix. Don't rush like Sam, don't just dump facts like Alex. Identify, apply, execute, verify, and present. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.